Welcome to the session on Client-Server Architecture. We assume that you have understood the prerequisite topics, namely Web Fundamentals and Computer Networks. This will help you in better understanding of this topic. In this session, we shall discuss about basic concepts related to Client-Server Architecture, its requirement and features, and we will also discuss different types of client-server applications and server types. Let us understand what is client-server architecture. Client-server architecture is an application design approach in which tasks are partitioned into two components, client and server. The client component requests for specific services or resources, and the server component processes the request and provides the requested services or resources to the client component. The rationale for separating the application into client and server components is that the server component of the application contains functionality that is commonly required by multiple users or clients, and it is not efficient to duplicate this functionality. In a real scenario, there will be one instance of the server component running and multiple instances of the client component that use this single instance of the server component. Server and client components typically run on different machines. The diagram here shows how the interaction between client and a server happens using a network. The server has to process requests from each client independently and send the response. Now, let us see some functionalities of the client component of an application. The client component is usually a front end of an application which provides interface to the user to interact with the application. An email client is an example of client program as it serves as an interface to send or receive emails over the network. Another example is web browser, which sends requests to the web server for web resources. Let us have a look at some important functionalities of server component of an application. The server component receives requests from clients and processes it. The request contains input data to the application which is provided by the end user. The server contains application logic and any other required data to process the request, and the results of the processing are sent back to the client as response. The client receives the response and displays the results to the user. Examples include mail server, web server, etc. We shall now discuss some important features of client-server architecture. It provides multi-user support wherein a single server can handle requests from multiple clients and the clients can share common server resources. Client-server systems also support transparency of location, which means that the client need not know the physical location of the server for getting its requests processed. In addition to this, client-server systems need not to have some platform at client and server machines. Platform here includes hardware, operating system, and other software systems required to run the application. For example, client machine may have Windows operating system. On the other hand, server may have Unix-based operating system. Another feature of client-server systems is that it is scalable. Scalability of an application is the ability to provide service without degradation in performance as load increases, and that can be achieved by introducing more number of servers in the network to process requests, and it makes the application easy to maintain. Let us see how the complete logic of an application is divided in general. The logic of an application can be divided into three parts or layers. The first layer is presentation layer, which offers a user an interface to provide inputs to the application and receives output. The second layer is business layer, which implements the functionality which meets the business requirements of the application. The third layer is the data layer, which stores and manages the application data which is processed by the business layer. Based on the distribution of the three layers of an application between client and server, we can have two types of clients. The first type is fat client, in which the client component contains presentation layer and bigger part of the business layer. The server may contain only the data layer and smaller portion of the business layer. On the other hand, in case of thin client, the client component contains presentation layer and smaller portion of business layer, and the server contains bigger part of business layer and the data layer of application. Based on the distribution of the application layers among client and one or more servers, a client-server application be 2-tier, 3-tier or n-tier application. In case of 2-tier application, the entire application is decomposed into two sets of services. The client combines presentation services and business services, and server handles data services. In case of 3-tier, application is decomposed into three sets of services, namely presentation, business and data. Client handles presentation service only as business service is moved to an application server, and a separate database server manages the data. In case of multi-tier, the application can be decomposed into client and multiple servers depending upon the complexity of the system. Here, we do have a pictorial representation of a 2-tier application. The client is containing presentation and the business services, and the server manages data services. Here, in 3-tier application, a separate application server is introduced between client and database server to handle the business services independently. Now let us discuss n-tier application architecture. N-tier application architecture divides the application into multiple layers. Each layer addresses some part of the business logic or data related aspect. It breaks the application into tiers and have multiple servers for applications and data. Each tier can be implemented independently and can interact with other layers. This way of developing applications makes the system scalable, flexible, and reusable, as if the developer wants to change technology for a layer or scale up. The whole system need not be disturbed, only the concerned layer need to be modified. In order to understand the need of a multi-tier application, let us consider a banking scenario. In the banking software system, there must be multiple applications like account management, loan processing, customer support, complaints management, transaction management, employee management, etc. These applications need to interaction among each other and need to process huge amount of data. This multiple interacting applications in an enterprise system make the whole system very complex, and most suitable way to handle the complexity is to distribute the functionalities among multiple layers. Consider the diagram shown here. Users can use multiple ways like internet banking, phone banking, or ATM to connect to a banking applications through internet. The user interacts with the banking application using the presentation layer available as a client program on user's machine, that is a computer system or a cell phone or an ATM. Now, based on the way of communication and request, user will be connected to a web server. Based on the type of request, the web server will get connected to an application server, and based on the data requirement, application server might contact to data servers. Here the complete application logic is divided into multiple layers. Client component at user's machine takes care of client-side validations and display aspect. Web server handles user requests and transfers it to different application servers appropriately. Application servers executes the business logic. For that, it might contact data servers to retrieve appropriate data. Let us discuss role of an application server. It provides business logic to an enterprise applications and ensures development, deployment and management of highly scalable, reliable and secure enterprise applications. It also helps in hiding the heterogeneity at data layer from the end user. Let us discuss role of a data server. It provides data services like storage, retrieval, and backup for an enterprise application. It is also referred as persistence layer. Some commonly used products to implement database server are Oracle, Microsoft SQL Server, MySQL. Let us summarize what we have learned. In a client-server architecture, client sends request. Server processes it and sends reply through communication network. On the basis of functionality, the client-server application is divided as presentation layer, business layer, and database layer. Based on the distribution of application logic and data, we can have thin or fat clients. Client-server application can be 2-tier, 3-tier, or multi-tier.